Now let's look at the derivative of an exponential function. Suppose y is equal to some function of x, and it's equal to e to the x power. Before we take this derivative, let's take the natural log of both sides, and we get the natural log of y is equal to the natural log of e to the x. And let's simplify that expression. We're going to write this as the log of y. And what is the natural log of e to the x? Well, remember that it is understood that the base of the natural log is e. So we're looking for the power or the exponent that the base e has to be raised to get e to the x power. And that's just x. So let's just rewrite this. X is equal to the natural log of y. And now let's take the derivative of x with respect to the variable y. And now we're simply going to use the rule that we derived for taking the derivative of a logarithmic function. And this is just equal to 1 over y. Now let's take the reciprocal of both sides of this last expression. And we could say that dy dx is equal to the reciprocal of the right side of this latter equation. And the reciprocal of that right side is equal to y. So our conclusion is that dy dx is equal to y. Well, remember what y was originally. It was e to the x. So if we look at our original function, y is equal to e to the x, this is a special case where the derivative of that function, dy dx, is simply equal to the original function, e to the x power. Let me give you one more example of this. Let's suppose now y is some function of x, but instead of just e to the x, it's equal to 3 times e to the x power. How do we find the derivative of this function, dy dx? Again, let's take the natural log of both sides. So the natural log of y is equal to the natural log of the right side, but using our rules of logarithms and the log of a product, we can say this is equal to the log of the number 3 plus the natural log of e to the x, which we now know is x. So let's rewrite this last equation as x is equal to the log of y minus the natural log of 3, which is just some constant number. So now, if we look at the derivative of x with respect to y, using our rule for the derivative of a logarithmic function, this again is 1 over y, and this is just a constant here, so the derivative of a constant with respect to y is equal to 0. And let's just take the reciprocal of both sides of this last equation, and we get dy dx is equal to y like we did before. So now we can say that dy dx is equal to y, but now our original y was 3e to the x, and the derivative of that function is again the original function 3e to the x power.